Today we're going to talk about systems of equations and different ways that we can solve these systems of equations. The first of which is the substitution method, which we'll focus on primarily today, and then the next couple of lessons we'll look at different methods. So let's begin with talking about what a system of equations is. A system of equations is a group of equations that are all on the same plane, meaning that each one of these is its own graph, but when we combine all of these different graphs on the same, XY plane, we start to see how they interact with each other, and more importantly, where they might intersect. Because the intersection of these different lines, let's say, and since we're talking about linear systems, these are lines in the same plane, we're going to find the intersection of these lines, and that's going to be the solution to this system of equations. So then the substitution method. Substitution, remember, means to plug something in, make it so what was there originally is replaced by something else. And that's exactly what we're doing here. This is a process of solving the system of equations that you're given, and you're going to solve for one variable and then substitute for that variable in the other equation. So we've got two examples today. Let's take a look. The first one, I've got equation A is y minus 1 equals x minus 5, and equation 2, or equation B, y equals 2x. So the first thing I have to do is solve for one of these variables. Now that's technically already done for us, y equals 2x. So with this, that means that everywhere on this plane, everywhere y is equal to 2x, whether it's in equation A or whether it's in equation B. So knowing that y equals 2x, I can then take this and plug this into the other equation, where the other equation starts y minus 1 equals x minus 5. Since I now know that y equals 2x, I can say that even though this is equation A, I can make this 2x instead of y here minus 1 equals x minus 5. Now, look at what we've done. We've got only one variable left. And here we know how to solve this. We're going to bring all the x's to one side. We're going to bring everything else to the other side and get this so it's just x equals. So let's do that. We're going to subtract an x from both sides. Two x minus an x is just going to give me a single x minus 1 is equal to, I'm left with negative 5 over here. Then let's add 1 to both sides. And I've got x equals negative 4. Okay, so that means that in this system, x is equal to negative 4, which means that in both equations here, where I'm looking for the intersection, x is going to be negative 4. I can then take this and plug this into either of these equations to find out what y should be. Now, since b looks a little bit easier for me to plug in this x equals negative 4 into, let's do that. b looks like this, y equals 2x. But now x equals negative 4, so y is equal to 2 times, instead of x, we're going to say 2 times negative 4. Well, that means y equals 2 times negative 4 is negative 8. Okay, this is the solution. X equals negative 4, and then y equals negative 8. What does that mean? Well, that means that since we're looking at a graph of these equations, a solution, or rather the intersection, is at negative 4, negative 8. So there's an intersection at negative 4, negative 8. And here I've graphed that for you. here's my first equation, here's my second equation, and if I were to put them on the same graph like I've done here, we'll see that the first one, this red line, is like so. I add in this blue line, and they'll intersect at this exact point, -4, -8. And that's the solution we're looking for, is when are they intersecting? Let's go back and let's do another one. Let's do this one. 3x minus 2y equals 0, and y plus 1 equals 2x. So remember, the first thing I want to do is solve for a variable. So I pick out which one might be easier to solve a variable for. I think in this case, I'm going to start with equation b. So b looks like this. Y plus 1 is equal to 2x. And I can subtract 1 from both sides here. And when I do that, I will get y is equal to 2x minus 1. And remember, y is equal to this whole thing. So if you want to put parentheses around that to indicate that y is this entire thing, 2x minus 1, that might be helpful. Because now that you know this, you're going to plug this into the other equation. So let's go over to equation A, which says 3x minus 2y is equal to 0. But since y equals 2x minus 1, then I can say that this is 3x minus 2 times. Instead of y, I'm going to replace y with 2x minus 1. And say this is still equal to 0. Okay, distribute. So I will get 3x, -2 times 2x, so this is going to be minus 4x, -2 times -1 plus 2 is equal to 0. 3x minus 4x, so this will be -1x, or -x plus 2 is equal to 0. And if I add x to both sides, I will get x equals 2. So this means in this system, every time you see an x, it is the same as 2. What I can do with this is I can plug this back into any equation here that I've got in this system and find what y is. So let's go back to b. I could plug this in right here and say y plus 1 equals 2 times x. Well, x equals 2. Or, since I kind of moved some things around, I could even use this, y equals 2x minus 1, since y is already alone on one side of the equal sign, and then plug in 2 there. So let's try that. I've got b is y equals 2x minus 1. I can plug in 2 for x and say y equals 2 times 2, and then minus 1. All right, 2 times 2 is 4, so y equals 4 minus 1. Y equals 3. So this is your solution. X equals 2, and y equals 3, which really means on my graph, if I were to put these on the same graph, there would be an intersection at the point 2, 3. Now let's take a look at that to confirm. So here are these two lines. The red one is that 3x minus 2y equals 0, looks like this. When I put the blue one on, y plus 1 equals 2x, I get an intersection right here at exactly the point 2, 3. So hopefully this gives you an idea of how to solve a system of equations, at least with the substitution method. In the next section, we will talk about how we can do this same thing, but with a different method. That's going to be using the elimination method.